All right, folks, so instead of a quiz this week, we've got this exercise 98A, which is just a whole bunch of practice on solution calculations that you're going to encounter wherever you go, whatever you do. You're going to encounter solution concentrations. So I want to point out, it's in the lecture, pages 913 to 918, and in your textbook, sections 9.6 to 9.7. Well, you probably noticed this page 2 in this exercise set with some examples. So, first one says, I've given the amount of solute and the amount of solvent, and it says, okay, what's the mass percent? Well, I have to frankly remember this. Concentration is solute over solution times 100% if I want to get to a percentage. So I'm going to do 52.3 grams of sodium chloride over what? Over 215.6? No. I'm going to do this. 52.3 plus 215.6. Now think about that for a minute. You might even stop the video and say, wait, why is he doing it like that? Well, remember, it's per amount of solution. The solution is the solute plus the solvent. So if I multiply that by 100%, and if that still doesn't make sense, stop the video and say, well, wait a minute, why is he using those numbers? I get 19.5% mass. Okay. Second concentration problem. I've got the concentration, I've got the volume, and this is one of those weird weight per volume or mass per volume. So again, I know what that is. Solute over solution. Solute is going to be in grams. Solution is going to be in milliliters multiplied by 100%. So I might just do this. I might just say, well, 3.12% equals solute over solvent. Well, now I've got that much 250 milliliter solution. There's my conversion. And that's the part I don't know. Oh, wait, grams of sucrose. There's my unknown. Mass volume percent equals mass of solute over volume of solution, grams per milliliter, times 100% to do the conversion. Well, stop the video and do that math, just to refresh your algebra skills. All right, you stopped it, right? And you're coming back now, and you've got the answer, and you got 7.80 grams of the sucrose, right? If you didn't, go back, refresh that algebra. It's almost certainly an algebra problem. Here's molarity. This is this one that's very specific to chemistry, but I do see it come up in the medical field, so okay. I've got 12 moles per liter of HCl. And I want to know how much of that stuff I'm going to pour out to give me 0.388 moles of HCl. Well, there's my relationship. Now, there's more than one way to do this, but this 12 means 12 moles of HCl per every liter of solution. And I'm trying to get to moles of HCl, or I'm trying to get to liters of solution. And they ask for milliliters, but we can make that conversion. There's 2 or 3 different ways to do this, but I could think about it this: 388 moles of HCl. And I'm trying to get over here to volume, milliliters, of solution. So I might say, well, okay, I got moles. I'd sure like to have liters over moles or something, and that would give me that. So I might think, well, do I have anything that has moles of HCl, a ratio of that to volume? Well, sure, liters. I can say, oh yeah, that's what that bottle says. 12 moles per 1 liter is implied. So that would get rid of moles, and I'm on my way to getting the volume. And well, wait, they did ask for it in milliliters. So I'd say, okay, liters are going to cancel. And I better plug in my numbers. 1 milliliter, 10 to the minus 3 liters. Now again, stop the video, do that math yourself. You did it, right? And you got 32.3 milliliters. If you didn't, stop, go back, figure it out until you get to the 32.3. Dilution. Now there's multiple ways to do this. You'll find things online, you'll find things in the book. If you strictly adhere to a sort of memorized formula, there's probably a 50-50 chance of you getting it wrong. And the stakes can be really high if you get a dilution incorrectly. So here's the way I say we're going to do it, because this is college level work, not $8 an hour memorization. Concentration, diluted or concentrated, equals the concentration, the other one, times the volume ratio. And again, we have to think, oh, well, volumes go up when I dilute, so one's bigger, one's smaller. Concentration goes down when I dilute, so one of these is bigger and one of these is smaller. So there's my logic. So I might have to sort out, okay, so there's nothing wrong with saying, okay, I have concentrated and I'm going to dilute it. And I could say, okay, volume of the solution to make 100 milliliters. Well, that's a lower concentration. 2.35 molar, 12.0 molar. 12 down to 2. So I know my concentration is going to go up. So let's see, what do I know? Blah, blah, blah. I want 100 milliliters of that. So, okay, well, I want 100 milliliters of this. So is this initial volume, is it bigger or smaller? Well, it must be smaller. You're going to take this small amount of highly concentrated, add water, so you bring the volume up and the concentration down. So I can pick either one. I might just go, I don't know, 12 molarity equals some volume ratio times 2.35 molarity. So I have to think, does the bigger one go on top or on the bottom? Well, the larger one must go on the bottom if I'm going to multiply 2 by something bigger than 1 to get me to 12. I go, oh, that's that volume of the concentrated stuff. So that volume is going to be smaller. So I'm going to say, okay, well, whatever that concentrated volume was, it's there. And I brought it up to 100 milliliters. And I know this will be greater than 1. Some number greater than 1 times 2 will give me that 12. Now, that's rusty algebra for some folks. I get it. But stop the video and do that algebra. You know it's got to be less than 100. So if you get like 500 milliliters, you go, no. I didn't take 500 milliliters of concentrated stuff and dilute it to 100. It must be less than 100. So stop the video and do that math, do that algebra. You did it, right? To solve all that, the volume of the concentrated stuff that you started off with, 19.6 milliliters. If you didn't get that, stop, go back, figure that out, dredge up that algebra. And then here's stoichiometry, just like we did back in chapter 6. Only the difference is, before we weighed the stuff to figure out moles, now we're probably going to measure a volume. I've got 0.84 moles of this lead 2 nitrate per liter. And I've got 1.34 moles of sodium chloride per liter of solution. I'm going to react this with this to form that. And I want to know, okay, if I have got this volume of that concentration, I'm going to start pouring this stuff in there. How much of this stuff do I have to pour in there to get the moles to work out? Well, first thing you've always got to do for stoichiometry is you've got to have a balanced chemical equation. So I think, okay, PbNO3 aqueous plus NaCl aqueous is giving me PbCl2 solid. So I have to go back to chapter 5 and think, okay, this is a precipitation reaction. It looks like the lead reacted with the chloride to give me that solid. To make that balanced, I can see, oh, I need 1 of the leads, 2 of the chlorides. That gives me 1 of the lead 2 chlorides, and I could figure out the rest of this equation. I take the other cation, sodium, and anion, nitrate, and I go, oh, there's also that. I look up my solubility rules. Oh, yeah, that's going to be aqueous. To make that balance, I've got 2. So if I know moles of the lead 2 nitrate, I can get some moles of the sodium chloride. If I know moles of sodium chloride, I can figure out how many liters I need to pour out given that concentration. Now we're going to run out of room here, so I'm going to go to a new page. So I'm trying to get volume, probably milliliters or liters, of the 1.34 molar NaCl solution. That's what I'm trying to get to. And what I'm starting off knowing is 22.35 milliliters of the lead. I'm just going to put 2 plus solution. And I know this is 0.840 molarity. That's what I know, and I'm trying to get to there. Well, there's a number of ways to start. And I might say, well, what if I start with this? 0.840 moles of the lead 2. I'm not writing the nitrate because it doesn't make any difference. Per liter of solution. And I start down this path, and well, I know one thing. It's 2 moles of Cl minus, or 2 moles of NaCl per 1 mole of the lead 2. Now I'm at moles of NaCl. And I might say, okay, what else do I know? Do I have something that has moles of NaCl in it? Well, the only thing I've got is moles per liter of that solution. So I might say, oh, okay. That was what, 1.34 for 1 liter. So right now, I would have, just to make this more clear, I'm going to say, well, this is the PbNO3 solution. And this is the NaCl solution. So if I got through all this right now, I'd have liters of NaCl solution per liter of the PbNO3 solution. And if I do that math, the number I've got in here right now, 1.254 liters of NaCl solution for every liter of lead 2 solution. Now, I just made this up when I sat down. I have no idea. I don't know. I'm going to just start playing with this until I get there. So we're back to chapter 1. There are 5, 6, 10 different ways to solve these problems. But now I've got this. I might say, well, what do I know here? I know 22.35 milliliters of the PbNO3 solution. Let's see. Maybe I'm going to pause this and write it in a smaller space. Okay. I just squeeze that together more. At this ratio, that's what after the first unit analysis, I was to this. Now I can see I've got milliliters of this solution. This is liters of this solution. Like, well, that's easy to fix. Milliliters, liters. I'd do the math and I'd be done. I know 1 milliliter is 10 to the minus 3 liters right there. So if I combine all this stuff, 1.254 times 22.35 times 10 to the minus 3 divided by 1 times 1. And the only units I've got left, liters, liters, milliliters, milliliters. The only thing I've got left are liters of NaCl solution. So stop and do that math. You did the math, right? I've got 0.02803 liters of the sodium chloride solution. Now we're not quite there because it did say they want that in milliliters. So okay, milliliters, 10 to the minus 3 liters, 28.03 milliliters of the sodium chloride solution. Now again, there are 10 different ways to solve that problem. I just thought this looked interesting to me when I started out. Where did I take that moles and I'll play with that and I'll go from there. There's not an infinite number of ways, but there are a very large number of ways to get there. There are some stoichiometry problems in the book, at least one, and I did one in the lecture notes. And I did it a different way. I just started down a different path, but they all work. All right, folks, so you're going to do, again, no quiz this week, but spend the time Wednesday, Thursday, Friday that you would have maybe spent working on the quiz, working on this. This isn't due until the next Monday, but that'll be fine. All right, folks, good luck. Hang in there. We are almost done. Bye for now.